In this installment of the FJ landcruiser build series, we'll be building the front suspension system from scratch. By installing triple bypass shocks, coilovers and a diff brace, our suspension will be much stronger and perform better than the stock system. And it should be able to do this as well. To do this design work, I used a 3D scanner, and let me explain why and how, and then we'll jump into the fabrication, machining and setbacks I encountered along the way. To do the bracketry on the Patrol diff, we're going to use a 3D scanner, and we're going to do the diff truss and the coilover and the triple mounts. Luckily for me, I've just been sent a Creality Raptor, which is a pretty good level consumer product. There are two modes that this particular scanner comes with. The first one is the blue light laser, which has improved accuracy and detail. And then the second one is just like the traditional infrared scanner, and I should be able to get rough geometry into CAD as well. So previously I haven't had a scanner. I've been begging, borrowing and stealing scanners off people, and I have done a lot of modeling with a tape measure, and I feel like I've done my time, and now I get to use one of these, and it's going to make my life a whole lot easier. There's a bit of a learning curve with these as well, but we'll try to figure it all out today. It is advertised that you don't have to use scanning spray and marker dots, but I do think they're probably going to give me a better quality scan. So I've got the poor man's version, which is baby powder and alcohol. This scanner can also be used on a Mac, which is excellent because I genuinely hate using Windows computer. I've used both for the last 10 years. The only thing the MacBook doesn't do is run engineering programs like CAD and FEA. So you can use that sort of parallel stuff, but I find that it really slows up the Mac. So I do use Windows every day for my CAD modeling, but this means I can scan on my laptop, which is awesome. If you open up the box, I have the handheld unit here, and I've got the cables to connect it to the computer and a power cable as well. Look at this nice case it comes with. Ooh, case. Not going anywhere. So let's go put this thing to the test. We'll scan some small objects first, and then we'll get into scanning the Patrol diff. I haven't done a heap of 3D scanning, so I thought I'd give it a go on some smaller items first. The scanner comes with a couple of scanning pads and marker dots to help increase accuracy, and really handy on these smaller items. Up first was my GoPro, and I was really impressed with the detail the blue light mode could get me. 0.1mm accuracy, and check the texture on the microphone and logo. Next up was the trusty old Kincrome measuring tape, and I set it up on the pad with a heap of marker dots. Using the scanning software is pretty intuitive, but does rely on you holding the scanner at the optimal distance from the object. It took me a while to get used to doing that, but once I did, it was actually really easy. Once I'd scanned the front and the back of the tape, I used the Creality software to combine both scans into one, and this is how it came out. Pretty cool to see the measuring tape with all the texture, I reckon. So for $2,500, I now have the ability to reverse engineer products, so watch out Kincrome, the designed and built measuring tape is coming to a store near you. Alrighty, so the aim of all this is to pick up these radius arm points here. Now obviously you can do it with a tape measure, but it is really nice to be able to do it with a scanner. So we'll scan this whole diff, pick up these points, design brackets, design truss. Okay, so we're using infrared mode with texture. We can start by moving it around. Parts we haven't scanned properly, so we go back over them, and then they turn green, which indicates we have a pretty good scan. And we're trying to keep it the optimal distance away. The scanner works really well, but on the shiny surfaces, it doesn't pick it up as well as it could. So what we're gonna do is use some isopropyl alcohol and some baby powder. Once I had the scan data, I brought it into CAD as a graphics body and set up the necessary reference planes. I could then model the diff using the scan data, essentially doing a sketch on top of it to get the right profile. Here's a comparison between my model and the diff, and you can see they're pretty bloody close. This allowed me to design the diff truss and shock mounts as well. I used a function on CAD to auto-profile all my parts to the diff I just modeled, which made life pretty easy. And you can see I've chosen to go with a full-length truss on this build. It'll gain around 5 kilos of mass, but the truss significantly increases the diff's second moment of area, which is going to increase the resistance to bending from heavy impacts, so it's an absolute no-brainer. In case you're wondering, it doesn't really affect the bump height either because the pumpkin is what gets really close to the sump. Okay, enough design chat, let's get onto the fabrication. Alrighty, so we've just cut and folded our diff truss bracketry and shock mounting bracketry. Now this was all done off the scan data using the Raptor scanner, so it's going to be really interesting to see how it goes together. So hopefully, again, it just goes together like a jigsaw. We've already gone through an extensive talk on welding diffs, and that's in the previous suspension video, so make sure you check out the link in the description below if you want to see that. But for now, we're just going to stick it together just like a big Lego kit. Like that, hopefully. This is a Nissan Patrol Diff with all its mounts completely shaved off, and if you want to know why we prefer using them over landcruiser diffs, check out the previous suspension video on my channel. Alrighty, so I just got done with the diff, and you can see the bracketry. It actually went together pretty well. This is what I want to show you because I'm pumped on it. And this is proof that the 3D scanner works. So you can see here that we managed to pick up perfectly the tube. These are all in the right spots. And then on the other side with the pumpkin as well, pretty much bang on. So you can see we've picked up that profile there, picked up all this profile here for the truss, and that one there as well. So really, really happy with it. There was just like the tiniest little bit of sanding, but to be honest, I probably wouldn't change the drawings or anything like that. It's just a little bit of variability in the actual diff. Like, look at all this. This just fits in beautifully. That there also, oh, how good's that? Shock just bolts up into there, and that's job done. So I've got a hole big enough so I can put a bolt head through the radius arm. We're just leaving this all tacked for now, same as the rear. We've got to cycle the suspension before we weld it off. We've opted to keep a radius arm front end on this build because it's strong, simple, and easy to package. These radius arms are made from Bisalloy 80, which is a high-strength structural steel. They adapt a Patrol diff to an 80 series chassis, and I have them on my build as well. We're pressing the bushings in before installing them on the car. So, front diff is in at ride height, use the same ride height space as the rear of the car, and really happy with it. So all of this bracketry, all pretty bang on. Yeah, it looks good. We just have to install the shocks now. So got to put the shocks in, do an upper mount, Panhard mount. I could also now check to see if my cast angle matched the CAD here, and luckily it did, which meant all my design work based off the scan data was accurate. We're trying to package our triples and our coilovers, and unfortunately this brace here that Laurie tacked on with confidence a couple of episodes ago is right in the way, so it's going to have to come out. So now it is time to mount the shock. So we're running a 12-inch 2.5 King's coilover on the front, and we're also running a 12-inch triple bypass shock on the front as well. I've gone over a lot of reasoning on why we're running both a coilover and a triple bypass shock, and that's in the previous suspension video. So make sure you check out that link in the description below if you want to see more on that. I'm going to go ahead and mock these up now. We'll put some temporary tabs in and then we'll do some bar work to tie it all off nicely. I was pretty confident the shock mounting should work, as I'd been able to check all my clearances in CAD before I cut anything. Temporary shock mounts tacked into place. Okay, so this is our old turbo, the ProCharge 67mm. And unfortunately, you can see here, if we try and run a shock tower brace over the top of the engine, it is not going to be pretty. So what I've convinced George to do is spend some more money to get exactly the same amount of horsepower, and we're going to change the manifold and the turbo setup on this car. We've got a really nice 6-boost manifold, and we've also got a new Wuhan war whistle. What it's going to do is bring this turbo way further down, and it's also got a V-band on it, which means I'm going to be able to clock the turbo, and it's going to be easier to do the plumbing. And then we'll be able to put the coil tower brace across very easily. What we're essentially doing is spending more money to make the packaging better on this car. There's really no performance benefits here. What we have here works really well, and we already know that, but we're gonna just change it a little bit just so we can get everything a bit lower and cleaner. Once that's done, we can work on getting these top shock mounts completed and then putting a brace across with some Camberg joiners. This is the replacement 6-boost manifold we've opted for, which we got from barratheworld.com. We've had bad experiences with aftermarket and DIY manifolds for Barras, but not these. And they come with a lifetime warranty, so let's put that to the test. We've changed turbo to the Pulsar G35 1050 as well.
We have taken out a 1,000 horsepower turbo lorry to put a 1,000 horsepower turbo back in. Oh, makes a lot of sense to you?
Yep, you could tell George was stoked.
Oh, look at that.
You happy where you are?
Yeah, mate, that's perfect there, actually. By the way, while we're at it, big thanks to Mez from Barra of the World for the upgrade, buddy. Thank you so much.
This is actually his personal turbo. He's just letting us mock it up.
We're taking it. It's never going to see this again. Yeah, that's not going anywhere, man. Wow, that's nice. Have a look at that, Richie. You can see here, this is now level with the top of the engine. So we should be able to bring that brace right down, which is going to be awesome. And it actually packages up really nicely. So obviously on my build, I've made a custom manifold, but this one packages up really nicely on the 4580s. Yeah, not too close to the engine mount at all. And then we've got an external gate going in there. We'll have to plumb that ourselves. And then, yeah, front to back, it's great. Like, we've got plenty of space for a dump pipe. The intercooler will be able to come around here. It's all, you know, it's all sort of working out really, really well for us. So now the new turbo and manifold were installed, we could start finalizing the upper shock mounts.
I was able to keep the shocks in the same position and then switch out to the final bracketry. Once I'd done that, I began reprofiling the tubes, which would form an integral part of the shock mounting. Alrighty, so we're going to put a flat plate in here, and then we're also going to run a brace across there, and that is going to make everything really, really strong. Plenty of 32 NB in this build. How good do these 6mm shock mounts look? The shocks are pretty much in now, so it's time to build Panhard mounts and a Panhard. I got the eye-to-eye measurement on the Panhard rod, and we're down at Stavweld Engineering, and we pride ourselves on making everything we possibly can in Australia, and that's what we're going to do today. We're going to make the Panhard from scratch. So I'm going to hand you over to Cameron, who's the resident machinist, and he's about to explain what he does here and how we're going to machine this.
Stavweld Engineering is a family business. It's been running for 25 years, and recently just got into making car parts. This is a CNC lathe. We're going to machine the ends for George's Panhard. So it starts out as a bit of round rod like this, and we drill and put the threads in on the CNC to suit whatever end we're making. So all steering arm ends and heams and all sorts of different stuff. All right, let's machine George's Panhard. Just testing the thread with the offset heam. Perfect.
Looks good. Ready to bolt up.
Just finished turning up George's Panhard. Now we're just going to chuck some flats on the ends so they can adjust it when it's in the car. Just finished up George's Panhard, which is going to go back and put it in the car. If you want any custom links made up for your four-wheel drive or project car, hit up Stavweld Engineering. Rich is going to put the links in the description.
Just having a look at this link now, it's really, really high quality. Beautiful finish on it. 7075 T6, and it's made in Australia, everyone. So support local manufacturing and buy from a company like Stavweld. And yeah, links in the description below. beautiful, beautiful piece of machining. I really appreciate it. I've already covered the benefits of using alloy links, and that's in the previous suspension video, so make sure you check it out if you want to know more. I just installed the custom length Panhard and it works perfectly. Really happy with it. So if you want to get any links machined, make sure you hit up Stab Weld Engineering, link in the description below. But yeah, looking really good. So that's pretty much the link setup for the front. We've got the radius arms and this Panhard, which is kind of standard, but then obviously we've got the triples and the coilover in there as well. I used the Raptor 3D scanner to do this whole front end, and it's all together now, and I can tell you that it made my life way, way easier. It is really a game changer. Now, I really also hate using that word, but for someone like me who uses CAD all the time and is constantly measuring with a measuring tape or verniers, the 3D scanner really, really does change things. It's easy to model basic shapes, but as soon as you start getting into compound curves and things like this Diff pumpkin, which just aren't super straightforward to model, then the scanner really, really makes life easier. And I just want to show you, prior to actually using the 3D scanner to design this front end, I tried to do the basic radius arm brackets out of just 6mm sheet. And what happened was I spent about half a day, I did 7 iterations and they were still wrong. And that was because I couldn't get the shape of the Diff pumpkin right in CAD. And after that, I just decided it's time to bite the bullet and get a scanner. So I'm really, really happy with the Creality Raptor, and it's gonna make my life easier going forward on the build. And what we're gonna do is do a whole bunch more 3D modeling, and we'll put all the bar work in CAD, and then we'll start mounting up off there as well. So the Creality Raptor gets the tick of approval from me. If you're already in the world of CAD and you're doing laser cutting or plasma cutting quite regularly and doing a lot of design work, then I would recommend getting one for sure. I can't believe that I've waited this long, but I'm so glad that I've got one now, and it's gonna make this thing go a little bit faster. That's the end of the front suspension for now. Obviously, we've still got a little bit to go with both the front and the rear end, bump stops and sway bars, and we're gonna get into that in another episode. So I hope you enjoyed this episode, and if you did, make sure you say so in the comments below, and don't forget to hit like and subscribe, and thank you so much for the support. I really appreciate it.